Good morning, students. Now, today's part of states of matter is derive the expression for molar mass of ideal gas equation. Derive the expression for molar mass by ideal gas equation, or derive the expression that is m is equal to mRT upon PV. Capital M is known as molar mass and small m it is known as given mass. Now, according to ideal gas equation, what is ideal gas equation? PV is equal to nRT. That is, yesterday we have already seen ideal gas equation. PV is equal to nRT. Therefore, N is equal to PV upon RT. The number of moles N is given by, what is number of moles? What is the formula of number of moles? Number of moles is equal to mass of gas divided by molar mass of gas. So, N is equal to M upon capital M. Therefore, M upon M is equal to PV upon RT. By substituting the value of number of moles, we get small m upon capital M is equal to PV upon RT. And on rearranging this equation, we get molar mass M is equal to mRT upon PV. Okay. So, this is the expression for molar mass by using ideal gas equation. Now, derive the expression for combined gas law. Combined gas law. Derive the expression for combined gas law. The ideal gas equation is written as, what is the ideal gas equation? PV is equal to nRT. Call it as equation number 1. And on rearranging equation 1, we get PV upon T is equal to nR. And it is constant. N is the number of moles, it is constant. And R is the gas constant. So, therefore, the product N and R is constant. So, this indicates that PV upon T, it is equal to constant. Therefore, P1 V1 upon T1 is equal to P2 V2 upon T2. That is equation number 2. The ideal gas equation used in this form is called combined gas law. The ideal gas equation, that is PV is equal to nRT. It is converted into P1 V1 upon T1. It is equal to P2 V2 upon T2. This equation used in the form of the ideal gas equation used in this form, it is known as combined gas law. Okay. Next one, अ सैम्पल. अभी यहाँ पर दो प्रॉब्लम दिए हैं, वो दो प्रॉब्लम टेक्स्ट बुक में है, सॉल्व किए हैं वो प्रॉब्लम सॉल्व करो. मैंने यहाँ पर सिर्फ क्वेश्चन लिखा है. ओके. नेक्स्ट क्वेश्चन इज डिराइव द रिलेशन बिटवीन डेंसिटी, मोलार मास एंड प्रेशर. Derive the relationship between density, molar mass and pressure. According to ideal gas equation, PV is equal to nRT. PV is equal to nRT. On rearranging equation 1, above equation is called as equation number 1. On rearranging equation 1, we get N upon V is equal to P upon RT. Call it as equation number 2. But N is equal to M upon M. N means number of moles, and number of moles is equal to mass of gas, that is small m, divided by molar mass of gas, that is capital M. So, N is equal to M upon M. On substituting the value of N in equation 2, we get, substitute the value of N in equation 2, we get M upon MV is equal to P upon RT. This one, small m upon capital M into V is equal to P upon RT. But density is equal to mass upon volume. Density, what is density? The ratio of mass and volume, it is known as density. So, therefore, D is equal to M upon V. So, therefore, D M upon V, यहाँ पर equation में है M upon V, that is D. So, therefore, D upon M is equal to P upon RT. By substituting the value of M upon V in the above equation, we get D upon M is equal to P upon RT. That is equation number 3. And on rearranging equation 3, we get M is equal to dRT upon P. This is equation number 4. Okay. So, this is the relationship between density, molar mass and pressure. Density, molar mass and pressure. Okay. Next part, state and write mathematical expression for Dalton's law of partial pressure and explain its and explain it with suitable example. Once again, state and write mathematical expression for Dalton's law of partial pressure and explain it with suitable example. Now, first of all, statement. The total pressure of a mixture of two or more non-reactive gases is the sum of the total pressure of a mixture of two or more non-reactive gases is the sum of the partial pressure of the individual gases in the mixture. That is the statements of Dalton's law of partial pressure. Once again, what is the statement of Dalton's law of partial pressure? The total pressure of a mixture of two or more non-reactive gases is the sum of the partial pressures of the individual gases in the mixture. Now, explanation. Dalton's law can be mathematically expressed as total pressure P total is equal to P1 plus P2 plus P3 at constant temperature and volume. Total pressure, that is P total, is equal to P1 plus, it is the summation of the partial pressures of individual gases in the mixture. So, the total pressure of a mixture of two or more non-reactive gases is the sum of partial pressures of individual gases in the mixture, that is P total is equal to P1 plus P2 plus P3 dash at constant temperature and pressure. Okay, where P total is the total pressure of the mixture and P1, P2, P3 are the partial pressures of individual gases 1, 2 and 3. Okay, and so on in the mixture. For example, consider two non-reactive gases A and B. Consider two non-reactive gases A and B. On mixing the two gases, pressure exerted by individual gas A in the mixture of both the gases is called partial pressure of gas A. On mixing the two gases, the pressure exerted by individual gas A in the mixture of both the gases is called partial pressure of gas A. Okay, say P1, call it as P1. Okay, here P1. Now, likewise, partial pressure of gas B, similarly, partial pressure of gas B is P2. Now, according to Dalton's law, total pressure of the mixture of gas A and B at constant temperature and pressure will be given as P total is equal to P1 plus P2. Okay. So, schematically, diagrammatically, the law can be explained as, the Dalton's law can be explained as, so here two containers are given, one container having pressure P1 and second container having pressure of gas P2. Okay. So, volume and temperature are constant for this gas. So, first container containing gas having pressure P1 and second container having gas containing gas having pressure P2. So, combining of gases, when two gases are combined, then the total pressure becomes P total is equal to, when these two gases are combined, the total pressure of the gas of mixture of gas becomes P total is equal to P1 plus P2. Okay. This is the Dalton's law of partial pressure. Now, next one, derive the expression that relates partial pressure with mole fraction of gas. Derive the expression that relates partial pressure with mole fraction of a gas. Okay. So, relationship between partial pressure and mole fraction. Okay. We have to derive the expression which shows the relationship between partial pressure and mole fraction of gas. Now, here the pressure of a pure gas is given by ideal gas equation. What is ideal gas equation? PV is equal to nRT. By using this equation, the pressure of a pure gas is given by the ideal gas equation, that is P is equal to nRT upon V. Here V and T, volume and temperature, are constant. Volume and temperature are constant. So, therefore, pressure is directly proportional to N. Pressure is directly proportional to N. Now, the partial pressure of individual gases, the partial pressure of individual gases can be written in the form of ideal gas equation as follows. The partial pressures of individual gases can be written in terms of ideal gas equation as follow. That is, P1 is equal to N1 into bracket RTV, because RT and V are constant. R is gas constant, temperature is constant, and volume is constant. So therefore, the above equation can be written in the form of ideal gas equation. P1 is equal to, for gas first, P1 is equal to N1, because pressure is directly proportional to number of moles. So that's why P1 is equal to N1 into bracket RT upon V. P2 is equal to N2 into bracket RT upon V, and P3 is equal to N3 upon into bracket RT upon V, and so on. Okay, so therefore P total is equal to, P total क्या आएगा, addition of these three equations, P total is equal to N1 RT upon V is equal to N2 RT upon V is equal to N3 RT upon V. Okay, so therefore P total is equal to, यहाँ पर प्लस आना चाहिए, इज इक्वल दिया है, सॉरी यहाँ पर इक्वल दिया है, इक्वल नहीं प्लस आना चाहिए. P total is equal to N1 into bracket RT upon V plus N2 into bracket RT upon V plus N3 into bracket RT upon V. एडिशन होना चाहिए वहाँ पर इक्वल दिया है, इक्वल नहीं है वो, हाँ, बाई मिस्टेक हुआ है, दैट इज माई मिस्टेक. ओके, सो दिस इज द टोटल प्रेशर. देयरफॉर बाय टेकिंग कॉमन RT upon V, ये कॉमन ले लिया तो क्या आएगा देखो, P total is equal to RT upon V into bracket N1 plus N2 plus N3 and so on. Okay, so therefore P total is equal to RT upon V into N total. P total, N1 plus N2 plus N3 is the total number of moles of gas, mixture of gas. So therefore P total is equal to RT upon V into number of moles, total number of moles, that is N total. Call it as equation number 2. Mole fraction of any individual gas, mole fraction of, what is mole fraction? Mole fraction, it is defined as the ratio of number of moles of any volatile component to the total number of moles of all the components in the solution. This is known as mole fraction. So mole fraction, it is defined as the ratio of number of moles of that component present in the solution to the total number of moles of all the component in the solution. Okay, so mole fraction of any individual gas in the mixture is given by the equation. Mole fraction of any individual gas in the mixture is given by the equation x1. So x1 is equal to N1 divided by total number of moles N1 plus N2 plus N3 plus so on, and that is equal to N1 divided by N total. So from equation 1 and 2, we get N1 is equal to P1 upon RT upon V. Equation 2 देखो क्या आएगा, equation 2 and 1, from equation 1 and 2 we get N1 is equal to P1 divided by RT upon V. Okay, that is equation number 3, and N total is equal to P total divided by RT upon V. This is equation number 4. By combining equation 3 and 4 we get इक्वेशन 3 एंड 4 को कंबाइन करने के बाद क्या मिलेगा देखो, यहाँ पर इक्वेशन 2 को क्या किया है, एन आर टी को यहाँ पर डिवाइड कर दिया पी टोटल को, है ना, तो N1 क्या आएगा, N1 इज इक्वल टू P1 डिवाइडेड बाय आर टी अपॉन वी. ओके, देयरफॉर एन टोटल number of moles of mixture of gas, that is N total number of moles, N total is equal to P total divided by RT upon V. Okay, by combining equation 3 and 4 को कंबाइन करेंगे तो क्या मिलेगा देखो, यहाँ पर N1 upon N total, देखो N1 एंड N total, 3 and 4 को कंबाइन कर दिया तो N1 ऊपर आएगा, N total नीचे आएगा. सो देयरफॉर RT upon V will get cancel, RT upon V कैंसिल हो जाएगा. सो देयरफॉर बाय कंबाइनिंग इक्वेशन 3 and 4 we get N1 upon N total is equal to P1 upon RT upon V divided by P total upon RT upon V. Okay, so that is equal to X1. This is mole fraction na? N1 upon, what is mole fraction? The ratio of number of moles of any volatile component to the total number of moles of all the components in the solution. It is known as mole fraction. So N1 upon N total, this is mole fraction, and it is X1. So therefore X1 is equal to P1 upon P total. This is equation number 5. So therefore P1 is equal to X1 into P total. P1 नीचे है, वो लेफ्ट में लेके गए तो मल्टीप्लीकेशन हो जाएगा. सो देयरफॉर P1 इज इक्वल टू x1 इंटू P total. This is equation number 6. Okay. Similarly, P2 is equal to x2 into P total. P3 is equal to x3 into P total, and so on. Okay. So thus partial pressure of a gas is obtained by multiplying the total pressure of mixture by mole fraction of that gas. Partial pressure of a gas is obtained. Partial pressure means P1, P2, P3, P4, P5, so on. Okay. So partial pressure of a gas is obtained by multiplying the total pressure of mixture by mole fraction, that is P2 is equal to x2 into P total, P3 is equal to x3 into P total, okay, and P1 is equal to x1 into P total. So this is the partial pressure. Okay. नाउ नेक्स्ट क्वेश्चन, मिक्सचर प्रॉब्लम है यहाँ पर. प्रॉब्लम देखो, प्रॉब्लम में टोटल बाद में ले लूँगा प्रॉब्लम्स. ओके, हर टाइप के प्रॉब्लम्स, फॉर्मूले सिर्फ आपको ध्यान में रखने हैं. मैंने सिर्फ यहाँ पर प्रॉब्लम लिखे हैं क्योंकि लॉग से प्रॉब्लम, टेक्स्ट बुक में लॉग से प्रॉब्लम नहीं दिया है, डायरेक्टली प्रॉब्लम सॉल्व किया है. तो आप लॉग से वो प्रॉब्लम सॉल्व करने की कोशिश करो. सो अ मिक्सचर ऑफ 28 ग्राम ऑफ N2, 8 ग्राम ऑफ हेलियम एंड 40 ग्राम ऑफ नियॉन हैज़ 20 बार प्रेशर. What is the partial pressure of each of these gases? टेक्स्ट बुक में ये प्रॉब्लम सॉल्व किया है, वो प्रॉब्लम आप देखो. नेक्स्ट वन, व्हाट इज वेपर प्रेशर, वाटर प्रेशर, व्हाट इज वाटर वेपर, सॉरी, व्हाट इज वाटर वेपर. सो आंसर इज द गैस अबव द सरफेस ऑफ लिक्विड इज कॉल्ड एज वाटर वेपर. The gas above the surface of liquid is called as water vapor. The pressure of the water vapor is known as vapor pressure. The pressure of the water vapor is known as its vapor pressure. Okay. Now, what is aqueous tension? Definition of aqueous tension. The pressure exerted by saturated water vapor is called aqueous tension. What is water vapor? Water vapor की definition क्या है? The gas above the surface of liquid is called as water vapor, and the pressure of the water vapor is known as its vapor pressure. Now, what is aqueous tension? Aqueous tension, it is defined as the pressure exerted by saturated water vapor is called as aqueous tension. Okay. Now, explain the how pressure of a dry gas can be calculated using aqueous tension. Explain how pressure of a dry gas can be calculated using aqueous tension. aqueous tension का इस्तेमाल करके गैस का प्रेशर, ड्राई गैस का प्रेशर कैसे डिटरमाइन किया जाता है. हाउ pressure of dry gas can be calculated using aqueous tension. Now here answer is, when a gas is collected over water in a closed container, when a gas is collected over water in a closed container, it gets mixed with the saturated water vapor in that space. When a gas is collected over water in a closed container, it gets mixed with the saturated water vapor in that space. Therefore, the measured pressure represents the pressure of the mixture of that gas and the saturated water vapor in that space. फिर से देखो, पहला पॉइंट क्या है? When a gas is collected over water, when a gas is collected over water in a closed container में वाटर में जो गैस कलेक्ट किए जाते हैं, it gets mixed with the saturated water vapor. When a gas is collected over water in a closed container, it gets mixed with the saturated water vapor in that space. Therefore, the measured pressure represents the pressure of the mixture of that gas and the saturated water vapor in that space. Okay. Now, the pressure of pure and dry gas can be calculated. The pressure of pure and dry gas can be calculated by using aqueous tension. It is obtained by subtracting the aqueous tension from the total pressure of the moist gas. It is obtained by subtracting the aqueous tension from the total pressure of the moist gas. That is, P pressure of dry gas is equal to P total minus P aqueous tension. Okay, so that is pressure of dry gas. Once again, what is pressure of dry gas? Pressure of dry gas is equal to total pressure minus aqueous pressure. Okay, and therefore pressure of dry gas is equal to P total minus aqueous tension. P aqueous means aqueous tension. Okay, so that is the pressure of dry gas. How pressure of dry gas can be calculated? Using aqueous tension. So pressure of dry gas, it can be calculated by subtracting aqueous tension from total pressure. Okay, now define and explain ideal gas and real gas. First of all, ideal gas. What is ideal gas? The gas or the gases which obeys gas equation over a complete range of temperature and pressure. The gases which obeys gas equation over a complete range of temperature and pressure are called ideal gas. What is ideal gas? The gas which obeys ideal gas equation. Ideal gas equation over a complete range of temperature and pressure are called ideal gas. Okay. For an ideal gas, the ratio of PV upon RT is equal to 1. आइडियल गैस के लिए प्रेशर, वॉल्यूम और RT का जो रेशियो है वो उसकी वैल्यू कितनी आती है 1. फॉर एन आइडियल गैस द रेशियो ऑफ PV अपॉन RT इज इक्वल टू 1. In an ideal gas, there are no interactive forces between the molecules and the molecular volume is negligible, small compared to the volume occupied by the gas. For an ideal gas, in an ideal gas, there are no interactive forces between the molecules and the molecular volume is negligible, small compared to the volume occupied by the gas. The gas particles are considered as point particles. These gas particles are considered as point particle. Okay, so this is ideal gas. Now what is real gas? Define and explain real gas. Real gas, gases which do not obey ideal gas equation. आइडियल गैस इक्वेशन ओबे करते हैं, लेकिन नॉन आइडियल गैस, रियल गैसेस क्या करते हैं? द गैसेस विच डू नॉट ओबे ideal gas equation under all the conditions of temperature and pressure are called real gas. So once again, what is ideal gas? The gases which obeys ideal gas equation over a complete range of temperature and pressure are called ideal gas. Okay, and for an ideal gas, the ratio of PV upon RT is equal to 1. And in an ideal gas, there are no interactive forces. Ideal gas में interactive forces नहीं होते. In an ideal gas, there are no interactive forces between the molecules and the molecular volume is negligible, small compared to the volume occupied by the gas. And the gas particles are considered as point particles. And real gases, the gases which do not obey ideal gas equation under all the conditions of temperature and pressure are called real gases. Okay, for real gases, the ratio PV upon RT will be either greater than 1 or less than 1. आइडियल गैस के लिए ये रेशियो 1 होता है और रियल गैस के लिए ये रेशियो कैसे होता है? आइदर इट इज ग्रेटर देन 1 और लेस देन 1. फॉर रियल गैसेस the ratio of PV upon RT will be either greater than 1 or less than 1. Now, real gases shows deviation from ideal gas behavior at higher pressure and lower temperature. Real gases shows deviation from ideal gas behavior at higher pressure and lower temperature. The intermolecular attractive forces are not negligible in real gases. रियल गैसेस में जो इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन होते हैं वो नेग्लिजिबल नहीं होते, आर नॉट नेग्लिजिबल इन रियल गैसेस. इन रियल गैसेस द एक्चुअल वॉल्यूम ऑफ द मॉलिक्यूल्स of the molecules cannot be neglected as compared to the total volume of the container. This is about real gas. Now point to distinguish between ideal gas and real gas. Okay, 4 points दिए हैं यहाँ पर. Differentiate between ideal gas and real gas. Okay, so ideal gas, first of all, first point, Ideal gas strictly obeys Boyle's law and Charles law. That is PV upon RT is equal to 1 in ideal gas. Ideal gas strictly obeys Boyle's law and Charles law, and real gas shows deviation from Boyle's law and Charles law at high pressure and temperature, that is obeys Boyle's law and Charles law at low pressure and high temperature. Okay, means real gases obeys Boyle's law and Charles law at low pressure and high pressure. So PV upon nRT is not equal to 1. PV upon nRT is not equal to 1. Second point, molecules in ideal gas, molecules are perfectly elastic. In ideal gases, the molecules are perfectly elastic, and in real gases, molecules are not perfectly elastic. Okay. Third point, in ideal gas, actual volume of the gas molecule is negligible as compared to the total volume of gas. Ideal gas, in ideal gas, actual volume of the gas molecules is negligible as compared to the total volume of the gas, and in real gas, actual volume of individual gas molecules is significant at high pressure and low temperature. Actual volume of individual gas molecule is significant at high pressure and low temperature. That is point number 3. Point number 4, ideal gas. In ideal gas, no attraction or repulsion between the gas molecules. आइडियल गैस में अट्रैक्शन और रिपल्शन नहीं होते मॉलिक्यूल्स में. नो अट्रैक्शन और रिपल्शन बिटवीन द गैस मॉलिक्यूल्स, दैट इज collision without loss of kinetic energy. Collision means mixing of gas molecules take place without loss of kinetic energy, and in real gases intermolecular attraction is present, hence collision take place with loss of kinetic energy. रियल गैसेस में इंटरमोलिकुलर फोर्स ऑफ अट्रैक्शन होता है, इसलिए intermolecular force of attraction is present in real gas, so therefore collision take place with loss of kinetic energy. And last one, practically ideal gas does not exist. Practically ideal gas does not exist, but real gases exist in nature, like O2, H2, CO2, N2, helium, etc. are real gases. These are real gases. Okay, so this is today's part of states of matter. Okay, next part हम कल देखेंगे. Thank you.